I've been doing a little off-camera work here, and I'm finding a few things I don't like. So I've been prepping to remove the table. That part's going okay, which is going to require unhooking the ratcheting assembly here. But in the process, I tried raising the table up, and or maybe knee, I'm not sure what you call it, but what I found, this is the elevation screw, input screw, and it's not frozen, but it goes to a kind of a worm type bevel gear that transfers to the vertical screw, and that vertical screw is frozen. I don't want to put too much torque on here. And unfortunately, to get to this screw, you got to come in from the bottom. So I'm going to end up having to pull this off the stand again. Okay, so that's a little bit of a setback. I was hoping that I wouldn't have to do anything with that, but yeah. The other thing is this this front foot with the adjustable leg on it here. The something is frozen in here. I was able to loosen this up, but and I don't know how much force it normally takes to adjust this, but it appears to be frozen also. But I don't think that's too big of a deal. I think that's just a matter of getting in there and doing some cleaning. Little midstream update. So we got the table off, and let's come back to that in a second, but I also have some good news. So this guy right here, the this feed stroke assembly, looked like it was severely worn, but it was just dirt and some old dried grease buildup. So this, good news, this looks fine. So I think that will be good there. Over here at the bench, so here's the table. Okay, there is the lead screw nut. There is some play in that nut, so I'm going to look at that and evaluate whether we're going to replace it or make a new one or what we're going to do there. Okay. We had one heck of a time. This is upside down, by the way. We had one heck of a time with this foot. Okay, and it would not budge. All right. So the problem was the clamping mechanism here. Okay. These little clamping pucks, they're made out of the Zamac material, and they're actually deformed. Okay. It's kind of interesting. And look at this. Look at this nut. I mean, it's been gronked on pretty good. Okay, let me see if I can take this off with one hand here. So you've got, that looks like probably a 5/16 bolt. You got a steel, puck here, spacer, washer. Okay, and that pushes on this guy, because this is all Zamac. And can you see that distortion? This thing's really been gronked down pretty hard. So not only has it worn into the cutout here, this is actually mushroomed and expanded out on the end. So it was stuck in there. And then this is the one that goes in the back. Same issue. This one was even worse. And if I can get this out of here, what they have. All right. As soon as I turned the camera off, it fell right out, of course. So they just cast in a hex here, and then they use this little brass nut. The rounded part goes down like such. Okay. So anyways, that's how that's made. I think what I don't like though is this shaft is not hardened. Okay, it's just regular mild steel. I think I'm going to make a couple of these, probably make them out of brass. This stuff, in my opinion, is just too soft. I don't want to make them out of steel because I think that may end up galling the support column here. Probably make these out of brass, and I can just thread the brass. I don't need to do this, and that'll still be fine. And I'm not crazy about this bolt. I'll probably make a new one with a different type of head on it. Probably just go with a square head so it matches everything else. That makes more sense. Okay, here's the retaining plates for the ways, and they are shimmed, and I've marked them with a letter punch so I know which is which. I need to measure and bag up these shims so I don't get them mixed up, although we're going to re-measure everything anyways. Okay, here's the lead screw, and it appears to be in pretty good shape. It's got the Zamac gear. Now everything was coated with grease, this blue looking grease, including the lead screw, which is not right. Maybe okay on the gear, but not on the lead screw. Okay, so we're gonna fix that when we go back together. Okay, here's the gib. It's got some dried up grease on here, but it looks like it's in pretty good shape. Okay, and then the actual way surfaces, they didn't do any scraping. It's just as machined. I don't know how far we'll go with these. If we'll just, I'd like to check them at least, you know, to see how flat they are. Looks like this side's got more wear than this side over here. Okay, we got the table off, no problem. And we solved the mystery of the frozen lead screw. It was actually the nut was frozen. I mean, it was really frozen on there, and it's because they greased it, and the grease dried hard, and it was like it was almost welded to the lead screw. So, you know, I soaked it with penetrant and solvent. Ended up having to warm it up just a little bit with a torch to get that old grease to liquefy, and now we got it moving. So I did some cleaning here because I didn't want to run any dirt through that nut. And this nut is Zamac, but you know what? It feels tight. There's no play in that. So we'll probably just reuse it. Okay, there we go. We're going to take off this this wedge part off of our feed nut here, and it's just for clearance. It's not anything critical. So, you know, rather than getting too elaborate, all I did, I got it in the collet block. I just put this on here and just bumped it around until that was level with our block. If I can do it all with one hand here, there are two hands, there we go. Okay, good enough. And I just got a scribe line on here of how far we need to go down. We're just going to mill it off. Alright, let's get it a little more aggressive. Go 40 thousandths. I just don't know how well that collet block is holding this. I got it pretty tight, but still. Alright, we're just about there. I think we'll just take 10 this time. We'll do a little closer inspection. Okay, I think we're there. Let me just check it off camera. Just doing the Mr. Bozo check here. Yeah. I think we're good. Seems to be matching up nicely. Okay, I got grandson number 3 here. Say hi, Ethan.
Hi.
He's going to help me with the edge finder. Okay, so he's going to let me know when the edge finder kicks over so we know when we're on the edge. Alright, you ready, Ethan? Okay, you watching that edge finder? Okay. Oh, what happened? You're supposed to yell out and tell me. Okay, here we go again. Ready? How about that? Sure? Is that good? Okay. I think you got it.
A little bit further back.
Okay, alright, so Ethan just double checked our setup here. We're ready to drill. We're on our scribe line and we're on center. Okay, pilot hole.
Does that look good?
How's that look? Is that gonna work?
No, it's too small.
It's too small?
Yeah, very too small.
Alright, we'll put in the bigger drill bit then.
Look how small that is.
That won't work, huh? Alright. Well.
And look how big this hole is. When this one.
Oh, okay, so we need to make it look like that one. He's showing me the old one.
I'm going to put it right here, okay? So remember what it looks like.
Okay. Okay, so according to the boss, Ethan, we need to make it look like that. Okay? Alright, so I'm going to put that over here. Alright. Safety glasses on. Okay, we're going to be throwing some chips, so we don't want to be too close here. Alright, here we go.
Okay, we're there.
Okay, we're through?
Yep.
All the way through?
Yep. All the way through. Grab the old one. Let's see if it's correct, okay?
Okay, wait till it stops. Alright, let me take the drill bit out, then we'll take a look and see what else is needed.
That's a lot of little small pieces.
Yeah, alright, so what do we need to do now?
I don't know.
You don't know? Well, look in there. Is there anything different? Can you see inside there?
Oh, it's a little bit smaller.
Yeah, but is there something else on the inside? Does it look like it's got threads in there? Because this hole is smooth, right?
Yes.
Okay, so we have to put the threads in. Alright, so that's a different tool. Okay, now this is a left-hand thread. So, which way do I have to turn it?
Left.
Left.
His left-hand
Very
one.
good. Okay, lefty tighty in this case. All right, here we go. Oop. Keep up with our tap fall over here. Break the chip.
And everyone gets all the way through.
Now you let me know when it starts coming out the other side. This is some tough stuff here. We gotta back
I
it up
see a little
little
bit coming out the bottom.
Oh, you do?
So
Okay.
it might be close. We're almost centered.
Almost there, huh? Okay. You know what we forgot to do? We forgot to put a little chamfer when we started this thread. got a little too excited. We can still do that, but we'll do it afterwards. Some tough stuff. We do not want to break our tap.
Do you have another one of those?
This is the only one we got.
Oh.
It just came in the mail today, even. So if we break this one, we're out of luck.
Yep, you might have to buy 5 more.
5 more?
Yeah.
Okay.
Because if that one breaks, then the other one breaks, then the other one breaks, and the other one breaks, and the other one breaks. Then you have no money. Then you're out of luck, right?
Right.
Well, you still get paid because you stayed at work longer, right?
So this is a kid logic here, okay?
We're pretty much done, right?
Yep, just got to take it out of there, and then we're going to put a little bevel on there because I forgot to do that. Okay, ready? We'll do a little chamfer just to make it look better and get rid of those little sharp burrs. Okay, I like that. We better do the other side too, okay?
Yep.
Okay, so we line that edge up so that we're lined up, okay? Alright, see how ugly that is? It's got a sharp edge on there. We're going to get rid of that sharp edge, okay? Okay, that's much better.
Let's see how it looks.
Okay, should we take it out of there and look at it?
Yep.
Okay. Okay. Let's move that so everybody can see. How's it look? Is that going to work?
Oh, they're the same size. They're the same size.
Okay. I guess I should hold it this way. That way they both look the same, right?
This one's just a... Oh, this one's a little longer.
Alright, we're going to fix that, okay?
Yeah.
Alright, good.
But
Thanks.
probably, yeah, we still the same ones.
Yeah, thanks for your help.
But some of it's stuck in there, right?
Yeah.
Some it's in there, but it's still the same.
Okay, we got to take it out of this block now.
Right here.
Right there? Just chop it off right there.
Mhm.
Okay.
Not the measuring tape, though.
Not the, oh, okay. Here's how that nut turned out. I didn't get a chance to film it toward the end there. I did test fit it on the lead screw and it fits really good. So happy with the way it came out. Okay, let me get a measurement. Alright, this is going to take a few minutes, so I'll bring you guys back when I get this tapped out. We're going to give our parting blade a try. This is always an adventure. So don't work on projects when you're tired. You guys probably noticed I forgot to chamfer those edges on that last part. Alright, let's face this guy off a little bit here. Parting tool did a pretty good job. We'll just get a fresh face cut here. This time we'll chamfer it. That's good. Okay. Double check what size drill bit I got here. Okay. Alright, this side just gets a clearance hole, so 5/16. Might be a little wicked when it picks up that other size hole there, and it's got a few threads in it too. Working on a bit of a measuring challenge here. So I want to reproduce these locks for the table foot. So the table's upside down. This is where the foot or table support would go. And then the locking pucks go in this bore here. There's one on the back side, one on the front side. Okay, and then they've got this radius in here that would match this, but the trick is figuring out the center line offset. So trying to figure out how to measure that. So what I ended up doing was just using a depth mic. This side here, this side's machined, and I had a little trouble. There were some burrs on here, so I had to stone this off. So I just came in with the depth mic and measured this distance versus this distance. And then had to do a little bit of math. So took the measured distance and then the radius of this guy and came up with 3.008. And then this one from this edge was this number plus the radius of this guy, which is a different diameter. It's 7/8. This one's 3/4. Added that, came up with this number, 2.416. subtracted the difference, and this is our offset, centerline offset between these two bores. So hopefully with that, I'll be able to go over to the mill and reproduce that little offset with a 3/4 end mill. All right, so let's go do that. Feeding really light because I don't have a real good grip on that collet. There's not a lot of insertion into the collet. We're almost there. Let me get a light. Just a tiny bit more. All right, I think we're there. A little bit of deburring. Let's check it before we do the other one. All right, guys, so ran into a little bit of a problem, and it was kind of perplexing. So I was very careful when we did all our measuring to figure out, you know, what our offset was going to be so that we would get a really nice contact with our radius here and the foot. And if we just hold these up here, I know you're not going to be able to see it, but I mean, our radius matches really good, and we've got about a 30 thousandths gap between our blocks when they're making nice contact, which should be fine. But when I put it in the machine and snugged it up, and I looked, and then I pulled the foot back out and looked at the spacing, it was like this. What the heck's going on? Okay, can you guys? Hopefully you guys can see that. So then I noticed we had the same problem on the originals. I figured out on these originals it was just the casting wasn't very accurate, and I wasn't too worried about it. So let me bring you over here and I'll show you what I figured out. All right, so what I've determined is that the bore for the lock that holds the lock slugs is not true. It's at a slight angle. So this is a crude way to measure it, and the only long piece of 7/8 material I had is this big valve. So I got a helper here holding this. So I'm going to measure, let me go this way so I can read it. I'm going to measure here, and I got 1.9774. Actually make that 1.976. 1976. If we come out here, I got 1928, 1.928. So it's definitely not bored true to the rest of the table, and I think that's what happened. So even though I carefully measured out here, because it's at an angle, I didn't get the right offset. So what I'm going to do is I'm going to put this back in the mill, and I'm going to take 5 thousandths that way, take a little more off, and then we'll recheck it. Well, guys, since that last clip, a whole day has gone by. Yeah, I just barely got going on this yesterday, and a friend of a friend of a friend came by with one of those hey man emergency projects. So I ended up doing some machining on a hydraulic pump magnetic clutch. So anyways, we got that taken care of for him. Didn't get any filming on that. It was a scramble to get it done. So anyways, I started with 5 thousandths, and then ended up going 10 thousandths. I set these back up in the mill, and I just used a piece of dowel to line these back up again, and then we milled in that direction this way to take a little more material off, and it worked out perfect. Okay, and then just to make the fit even better, I went in with some lapping compound. I know it's probably total overkill, and lapped these in. And let me see if I can show you. See the dull part of the cut there? So that's everywhere the lapping process was making contact. So only right here is the only little piece that was not making contact. So man, that's really good. This is the one, oh wait a minute, I got them backwards here. Okay, so this one is the one that doesn't have any threads. So it actually looks a little better because it can float a little more, where this one has the thread. So when you're tightening it up, it puts a little, you know, twisting torque on it. So it's if you get the light just right, you can see there's a little more removal on one side versus the other. But man, the fit is really good and feels much, much better. I cleaned everything really good. You know, normally lapping was not something you want to do in a moving machine part, because you'll never get all that compound out. But this hardly ever moves. You'd make a couple adjustments, you know, just a couple times a day. It just, you move it once, you lock it. So it's not like we're going to be, you know, continually rotating that shaft or moving this around on a continuous basis. So I think it'll be fine. All right, let's move on. Oh, and I don't know if I mentioned this on the other one, but just to add, so I'm pretty sure that's why these original ones have all the wear marks up toward the nose of the cutout here. It's because it was not on center. So I don't know if this is a common thing, but you know, if you're doing one of these, you know, just be aware that that you know, that you may have the same issue. Okay. Just giving you guys a look in here. So I put the support column in, snugged it, and then carefully pulled it back out. So that's what our fit looks like down inside the bore there. Yeah, I know how exciting it would be to throw in, oh, maybe 2 or 3 hours of paint prep and sanding and masking and so forth. But in the interest of time, I think I'll just throw a few still shots in for you guys. How you doing, Ethan? You almost through?
No. Halfway.
Halfway, okay.
Not even halfway.